recognize the elderly person who doesn't like his own TV set to watch the program? Well, he might be a common person like us who couldn't resist to get the experience of a new TV set which looks better than the old one. But one may ask us a question. How can one TV set be better than another TV set? Is there any difference in the specific features of the TV sets in relation to the picture quality or clarity? Let me be more specific here. This old gentleman was watching his TV in standard format or SDTV, whereas our young friend was watching it in what we technically call as high definition television or HDTV. Here I am referring to the difference between SDTV and HDTV. Believe me, if the old person would have been John Logie Baird, he wouldn't have been surprised. Rather, he would have been extremely happy to see his dream of watching the television in high definition coming true.
John Logie Baird, a Scotsman who was the first person in the world to demonstrate a working television system. On January 26, 1926, John Logie Baird demonstrated a viable television system using mechanical picture scanning with electronic amplification at the transmitter and at the receiver. The video signal could be sent by shortwave radio waves or over ordinary telephone lines, leading to the historic transatlantic transmissions of television signal from London to New York in February 1928. Today, almost every home has a television set.
Although television today works on a different system from Baird's. He was the one who had envisaged almost all the advancements in the field of television that we experience today. He had dreamt of giving people colored picture with depth, that is 3D or three-dimensional, which would look a lot more real than a flat 2D or two-dimensional one. He also envisaged a system that would make TV pictures extra sharp and clear. Since the time John Logie Baird in the early 20th century invented the first TV, the technology has advanced to a great extent, including the principle of signal generation and transmission or reception process.
In 1985, two authors, Matthias and Patterson, predicted something very interesting about the television technology in their book, Electronic Cinematography. In their words, the future of electronic cinematography lies in high-definition television. When video images achieve a resolving power comparable to images recorded on 35mm film, electronic cinematography will begin to realize its full potential. Conventional television receivers used a modification of the cathode ray tube CRT, and these sets were quite bulky and fragile due to their glass vacuum dome. With advances in materials and technology, the TV screens are less bulky, miniaturized, and are becoming popular, although they are little costlier.
Let us now move to actual television system. Any television system comprises of two sections, that are audio and visual sections. When any scene is shot for television, the visual is picked up by the camera, while the audio is caught using microphones. Every TV system has to transmit these audio and visual signals in synchronization so that they are reproduced faithfully at the receiver end. We all know that while the audio signal transducers, that is, microphones, take care of converting the audio signals into electrical signal, TV cameras convert the visual signal into electrical signal.
In order to understand that how a picture or visual signal is reached till the viewer, let us quickly understand the main building blocks of a typical communication system. There are two ends of any communication system, namely a transmission end and a receiving end. The signal to be sent is picked up electronically by a camera at the transmission end. It is processed for making it suitable for its journey till the receiver end. This includes amplification, modulation, and transmission through a medium like air. At the receiver end, the signal is demodulated, amplified if necessary, and then presented to the viewers in audio and visual form through television set in our homes. Now, when the signal is sent through a medium via an antenna, it has to be sent in a serial form, meaning the signal amplitude keeps on varying with time continuously. This is easily done in the case of audio signal. Like I'm speaking to you in serial form, one word after another, and you are listening to me in the same order serially.
But this is not exactly true of the picture or video signal. As you know, a picture has many points which give out light simultaneously. In electronics terminology, these points are called picture cells or pixels. The intensity variation at these points for any color is the signal. The optical signal emitted by many points of the picture or scene is received by the lens in our eye simultaneously or parallelly. The visual signal seen by our eye at any instant may be considered to be originating from a two-dimensional source. Now, in a communication system, this data should be sent over to the medium of transmission simultaneously. Let's imagine we are using optical fibers for transmitting them. We will have to divide the picture in small parts and assign one fiber per part. To send a picture of a postcard size, we will require to bundle hundreds of fibers together so that the information from each point of the picture reaches the other end. One would appreciate that this is not a very viable solution if we want to take the signal even few meters away, let alone thousands of kilometers, that the video signal has to travel in practical situations.
To overcome this problem, a very ingenious way has been devised which is based on the persistence of vision property of our eye. Our eyes can retain the image once seen for about 60 milliseconds interval. It means that even if we remove the image and place it again before this time interval is over, then our eyes perceive that as a continuously visible image. This property has been used in screening the movies by projecting sequence of images taken on the film to give the viewer a feel of an uninterrupted motion. Persistence of vision also comes very handy in transmitting TV signals using an antenna. For this, first we need to convert the picture signal, which is parallel in nature, into a serial form, and then it can go for transmission via a transmitter antenna. This is done by scanning or rastering process. A picture frame to be transmitted is segmented in different horizontal lines. Then each line is scanned pixel by pixel from one end to the other. Then the scanner is moved to the next line by retrace line. Retrace in horizontal for every line. This way the picture is converted to a serial form which contains information about light intensity at every pixel. This information is transmitted serially. At the receiver end, in our TV sets, this signal is received and shown on the screen using the same format that was used to initially scan the picture. So you can see one which is the exact replica of her original picture. When we read a page, we read it from left to right and up
to down. In TV, it's similar, but sufficiently fast scanning is used so that our eye sees the picture as a whole and not as a scanned one. Now, this process of horizontal scanning was good for transmitting one picture frame, but in television we need to transmit the frames continuously. Hence, once we reach the end of the first image, we need to begin the horizontal scanning once again. So, we again go back to the left-hand top corner by what is known as the vertical retrace. The vertical scanning is similar to horizontal scanning, except for the obvious difference in the direction of movement and the fact that everything happens much more slowly. There are typically 833 pixels per line and 625 lines per frame. So, the new frame is traced after scanning 5,20,625 pixels per frame. The number of pixels per frame is nothing but product of the number of horizontal lines per frame and the number of pixels per horizontal line.
When we transmit the TV signals from the transmitter, it gets received by the TV sets manufactured by various companies. All these TV sets should display the same TV picture as is transmitted by the TV station. To ensure the uniformity in the reception, the signal is sent following some set standards with regard to the number of horizontal lines and number of pixels per line, as well as frames per second are standardized.
There are mainly two formats: National Television Standards Committee (NTSC) and Phase Alteration by Line (PAL) for color systems. In India, we use PAL-B system, which is a variant of PAL system.
All these standards have 4:3 aspect ratio. This is the ratio of horizontal to vertical dimension of the receiver picture or transmitter camera tube.
There was a time when a salesperson in a TV showroom used to quote the rate for 14-inch or 21-inch TV set. Even today, if we go to a TV showroom, we would find the specification written below the TV screen: 81 cm or 32-inch LED display, and so on. If we watch carefully, we would notice that our TV screen is in rectangular shape. Then does 14-inch or 21-inch refer to the height or width of the TV screen? Confusing, isn't it? Actually, a salesperson neither refers to the height nor to the width of the TV screen, but refers to the diagonal of the rectangular TV monitor or screen. Now you would be curious to know that instead of specifying the dimension of TV screen in two dimensions, that is height and width, why is it expressed in one dimension, that is in terms of diagonal of the rectangle? How could a diagonal of a screen represent the height as well as the width of a screen?
Let's try to understand that why is it so. If we consider 4:3 aspect ratio, the width of the screen is always 1.33 times its height. For a given rectangle, we know that the hypotenuse is expressed as the square root of the sum of the squares of both sides. So, just by specifying its length and also remembering that the width-height relationship is 1.333:1, we can always work out the actual dimensions of the screen. For example, a 21-inch screen will represent a rectangle with 16.8 inches width and 12.6 inches of height. But here, the question arises that how the aspect ratio of 4:3 for TV screens was adopted in the first place.
In the earlier days, TV was essentially competing with the movies screened in the theatres. At that time, most popular film format used for picturizing the movies was 35mm perforated film. The perforations were made to pull the film on the sprockets of the projector. The negative in 35mm movie film, after subtracting the space occupied by the perforations, results into effective dimensions of 24.9 mm into 18.7 mm, which is nothing but 1.33:1 or 4:3 aspect ratio. So, it was thought that if television began its life with tubes of the same aspect ratio, movies could be broadcast without any modification in the frame size. But after all, our two eyes are set side by side, and so their field of view has an aspect ratio a good bit wider than 4:3. The televisions in PAL or NTSC standards have respectively 625 or 525 horizontal scan lines per frame. To avoid seeing these raster lines, we are supposed to sit at least 7 screen heights away from the TV screen. When we view the TV from that far, the image we are watching will occupy only 10 degrees in our horizontal field of view. Now, let's look at the HD TV or so-called high definition picture. First of all, its aspect ratio is much wider. 4:3 has jumped to 16:9, or in the film nomenclature, 1.33:1 has become 1.78:1.
In addition, it has almost twice as many lines vertically, 1050, improving the resolution radically. Since the lines are now placed nearer to each other, we will not see them even if we watch the TV from a nearer distance. This effectively further enhances the angle of viewing. The earlier TV displays were made of cathode ray tube or CRT in short, which was essentially an evacuated glass enclosure where electron beam was shown on a fluorescent screen to generate the picture for viewing. Due to complicated construction of the CRT, the choice of dimensions of the screen were very limited. With the use of light-emitting diodes LEDs, liquid crystal displays LCDs, solid-state plasma devices in the manufacturing of the TV screens, the dimensions of the screen can be as large as required, with any choice of aspect ratio. This has made it possible to build the TVs with large screens which will be able to give a lifelike experience to the viewers.
Any of these widescreen formats is a better approximation of the human visual field than the boxy, nearly square shape of a TV screen. In addition to the enhanced viewing experience due to wide angle provided by the new aspect ratio, the HD TV also has smaller pixel size, typically having 1080 lines of 1920 pixels each. This is almost 4 times more information than the standard TV. Now let us actually experience the production process in SD as well as in HD TV format. Is it not an amazing experience to watch TV studios used for SD format and HD format shooting? Technology has been constantly redefining television. We need to keep a watch on technology which is moving extremely fast. Unlike regular television, a tiny box in a room, HD TV cannot be ignored. Who can read a magazine in a movie theatre? Ultimately, the whole experience of watching television is going to be different. It will be a cinema experience.